Alright, we're going to be talking about slope of parallel and perpendicular lines. Hopefully you know what slope is from algebra. That's your rise over run. Okay, it's how inclined a line is. Okay, the slope formula that you learned in algebra was m equals y2 minus y1 divided by x2 minus x1. Okay, that's your change in y over your change in x. Okay, we're going to be talking specifically about slope of parallel or perpendicular. Okay, in this one, we're talking about parallel. So if you have parallel lines and you want to know, we want to know how their slope compares. So draw in your notes this figure on a grid. Okay, we have two lines and we're going to count the slope. So if we count, we pick 1 point and any other point. You can pick any 2 points. Okay, I've got mine picked out on here already. Okay, so when I count rise, I'm going up 1, 2, 3. And my run, 1, 2, 3, 4. Okay, so the slope of this line is 3 over 4, rise over run. Okay, and this second line has the same rise and the same run. So the slope is also 3 over 4. Okay, so what you should notice here is that in a coordinate plane, two distinct lines are parallel if and only if their slopes are equal. Okay, so parallel lines have the same slope. Okay, parallel lines is same slope. Okay, and you have this conjecture written down. Perpendicular lines, we're going to look at two perpendicular lines on a coordinate plane and see how their slopes compare. So this slope obviously is negative because when we look at it from left to right it's going down. So we know it's a negative slope and we're picking 2 points to count rise over run. Okay, so from this point to this point, okay, it's got a run of 3 and a rise of 4. But notice from here to here, my rise is actually down 4. Okay, so that's a negative 4. So I'll go down 4 and to the right 3. Ignore that. So this has a slope of negative 4/3. Okay, and this slope of this line, okay, we can use this same point where they intersect and this point. Okay, so my rise, okay, in this case, the direction I'm counting here, you may say is down 3, and you can say down 3 if that's the way you look at it. Okay, but if you're going down 3, you also have to go to the left 4. The left is also a negative movement. So a negative divided by a negative is actually positive. So this is positive 3/4. So look at how these two compare to each other. Okay, they're the same numbers but reversed in the fraction. Okay, when you flip a fraction, okay, that's called a reciprocal. Okay, so this one is a negative 4/3 and this one is a positive 3/4. So we've changed the sign and flipped the fraction. Okay, so your perpendicular slope property says that in a coordinate plane, two non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. Okay? Or you could say opposite reciprocals. Opposite means they're different signs. Okay, so you may want to make a note that we'll often call this opposite reciprocals. Okay? You'll hear me say flip the fraction and change the sign. Okay, and remember this is with perpendicular, meaning lines that intersect at a 90-degree angle. Okay, so if you want to make note of that. Okay, means they're meeting at a 90-degree angle. Okay, they're opposite reciprocals. You flip the fraction, change the sign. So we're going to practice a couple of problems. This first one says that we have points A, B, C, and D, and it gives us the coordinates. They tell us that AB and CD, they ask, are AB and CD parallel, perpendicular, or neither? Okay, so we're going to look from A and B. We're at -15, -6, and +6, +8. Okay, so here I'm not given a picture. I can't count my rise over run. If you wanted to graph this, you could and count, or you can use the slope formula, which I showed you on that first slide. Okay, so first I'm going to label this x1, y1, x2, y2. Okay, those are my points for line AB. So y2 is 8 minus I should have put in 1 there. x1, y1. Okay, so y1 is -6. I already have a minus because of the formula, and this is negative. So minus a negative actually changes it to plus. Okay, x2 is 6 minus, and then x1 is -15. And again, minus a negative changes to plus. So 8 and 6 is 14. 15 and 6 is 21. This fraction can be reduced. They are both divisible by 7. So that is 2/3. So the slope of AB is 2/3. Okay, now we're going to do the same thing and check the slope of CD. x1, y1, x2, y2. So my y2 is 10 minus -2 changes it to plus, -4 minus 4. Okay, 10 plus 2 is 12. -4 minus 4, okay, so that's a -8. Okay, these are common factors we can get out of both. The highest, I believe, would be 4. So if we divide out of 4, we're left with 3 and 2. But don't forget your minus, your negative here. Okay, and that is the slope of line CD. So if you look at how these compare, we have 2/3 and -3/2. Okay, parallel, they should be the same. These are not the same, so they are not parallel. Perpendicular, they should be opposite reciprocals. Okay, did we flip the fraction? Okay, so 2/3, did it become 3/2? Yes. And did we change the sign? And we went from positive to negative. Yes. So these are perpendicular lines. Okay, because their slopes are opposite reciprocals. Okay. This one gives you points E, F, and Q. Okay, so the EF forms a line, and then they have point Q, and they want to find point P somewhere so that line PQ is parallel to EF. So we want the lines to be parallel, but we want to know what are the possible coordinates of P. Okay, again, we know if they're parallel, the slopes have to be equal. Okay, the slope of PQ has to equal the slope of EF. Okay, so the first thing I need to do is find the slope of EF. Okay, you can, since you're given a graph, count rise over run, or you can use slope formula. Okay, remember slope formula is y2 minus y1 over x2 minus x1. Okay, y2, this could be my second term, so it'd be -4 minus 0. 5 minus -3, minus a negative changes it to plus. So -4 minus 0 is still just -4, and 5 plus 3 is 8. This can reduce. 4/8 is 1/2, and don't forget your negative. So -1/2. So we want our slope to be negative 1/2. Now we know one of our points is Q. We can call this x1, y1, and we're trying to find x2, y2. So if our slope formula is y2 minus y1 over x2 minus x1, okay, this equals my slope. The slope is the rise over the run, the change in y over the change in x. Okay, so now I'm going to plug some numbers in here. Okay, so the first number I'm going to plug in, I'm going to actually completely rewrite this. My slope, I know. I want my slope, it's negative 1/2. Okay, you need to choose where to put the negative. It can go on top or bottom. I'm just going to go with the top. So we want our slope to equal. Okay, and on top it's y2 minus y1. Well, we know y1 is the number 2. So our missing piece minus 2, our missing piece minus x1, which is 4. Okay, so now I can look at these as two separate equations. So I'm going to look at the top and solve this. So in the top I have negative 1 equals y minus 2. I'm solving for y, so I'm going to move the 2 over by adding. Negative 1 plus 2 is positive 1. Okay, now I'm going to look at the bottom as an expression, okay, to find x. So in the bottom, I have 2 equals x minus 4. If I move the 4 over by adding, that leaves me 4 and 2 is 6. So x is 6. So for one of my possible points for P would be an x value of 6 and a y value of 1. So that would be written as 6, 1. Okay, so that's a possible value or location for point P. And if you want to check yourself, go to 6, 1. 1, 2, 3, 4, 5, 6, 1. Is that on? And it is. Okay, that's how you do it. Make sure you have your notes. You understand that parallel means same slope, perpendicular means opposite reciprocal slope.